Hey guys, what's up? My name is Gabe and this is Games with Gabe. This is the next episode in the Coding a 2D Game Engine in Java series. In the last episode, what we did was we implemented the drag and drop functionality of our level editor. This is great, but now we want a way so that we can actually order these on a nice tile map. So what we're going to do in this tutorial is start adding debug drawing facilities. So these debug drawing facilities, as you can see right now, are going to help you to draw lines just anywhere at any time. This is really helpful for things like physics when you're trying to debug, like if a velocity is pointing the right direction or something, or even if you're just trying to debug different things about your game. So this will be a nice function to have in general, but it will also allow us to draw our grid lines. So hopefully what we'll get to is having a grid drawn by the end of this. If not that, we will have a nice debug drawing facility at the very least. Okay, so let's get started. We're going to look at how this works and then we're going to actually implement it. Now I know what you're probably thinking. You're probably thinking, drawing lines, what kind of explanation do we need for that? And normally I'd be like, yeah, you're right. I mean, drawing lines is one of the simplest things ever, but in OpenGL, nothing is simple. And if you go into lower level rendering APIs, it gets even more complicated. So how do you draw a line? Well, let's start with the basics. So say we've got some lines here. We know this is at x1, y1, z1. We know that this is at x2, y2, z2. And remember, we do need these z coordinates because OpenGL is a 3D rendering API. So no matter what you want to do, we're always going to have those. This line has the same thing, just some different coordinates, and this line also has some different coordinates. Now, how do we send these to OpenGL and then tell OpenGL, hey, I want you to draw some lines here, here, and here? Well, there's a couple ways we could go about it, okay? So the way that I first did it was I actually turned these into quads. So instead of drawing lines, what I did was I drew very thin quads. And I did the same thing over here. And then I would do the same thing over here. And the benefit to doing something like this is you get control over each individual stroke width. You can make these as fat or as thin as possible. And you get more control over the way they look. You can add joints like caps at the end of them if you want. You can add all sorts of other things too. You can get crazy with it because it's a piece of geometry now. It's not actually a line. And that's useful because if you want to have control and make your lines look nice, then you would probably want to do something like that. It's also a little bit more complicated. So what we're going to be doing is we're going to be using GL's built-in GL lines. Now this works similar to GL triangles. So if you'll remember, we had that function GL draw arrays and we would pass it in GL triangles or draw elements in our case. This time what we're going to be doing is we're going to be drawing lines. And so what this expects is it's going to expect some coordinates. And so basically it'll be like, okay, vertex 1, vertex 2, which would respond to this vertex 1, and we'll say this is vertex 2. This is v3, v4, v5, v6. So then it would expect v4, v3, or v3, v4, it doesn't really matter, and then v5 and v6. And this would all be passed in one big array. Now remember, in GL we define what our vertices look like. So in our case, what I'm going to do is I'm going to say one vertex actually looks like this. It's going to contain x, y, z, r, g, b. So we will have our position and we'll have the color of the line for that vertex. And the color will stay the same for two vertices. So this will be red, this will be red. That will never change, but we can't really tell it that. So what we'll actually be passing in is 6 floats for each of these vertices. And this will actually be an array full of 1, 2, 3, 4, 5, 6 times 6, 36 floats. So this would actually be like 36 numbers. And it would just look like x, y, z, r, g, b, x, y, z, r, g, b, over and over and again until we got all 6 of these vertices done. The reason for that is because we're going to be sending these as something called the VBO, the VAO, right? So we're going to be creating this VAO, which is just an array object inside our GPU. Then we're going to bind a dynamic VBO so that we can upload these dynamically every frame, just like our batched rendering. Now, one more thing that I'm going to mention before we start coding is there is one other thing that you typically want to control. I didn't think about this at first. I was reading through Game Engine Architecture 3rd edition, I think, and The author was one of the guys who worked on Naughty Dog's Uncharted series. And he gave a description of their rendering API, and I saw something that I really liked. And it was like, okay, if you want to draw a line, what you need to pass in is the start position, the from to, so you're drawing it from here to here. You want a color, and you want a lifetime. I never thought about this part, but it's super useful because there are many times when you want to shoot a line out and you want to be able to see that for maybe like 10 seconds just that you can see where this is, but you don't know, but you can only draw it once, right? So like if your physics code hits at the ground and you want to draw the ray that it's supposed to bounce off at, you're probably going to get one frame to draw that ray. So you would draw it and say, hey, stay on the screen for 10 seconds, and then it'll stay on the screen for 10 seconds. So lifetime is super useful. One other thing they had is stroke. I did add that, but since we are doing it with GL lines, at least for now, we can't actually individually control the stroke for each line. If we were doing GL triangles and we actually made these into quads, we could, but we can't do that. So we will stick with just these 4 parameters for now. Okay, so that's sort of the basics. Let's actually see how to draw this or code this. Okay, so first thing I'm going to do, let's go into our render package, create a new class, and we're going to call this line2D. So line 2D is going to be just our 2D lines. We're going to need a few variables with this. Let's actually do vector 2f from private, and you can also call these start and start and end if that makes more sense to you. It doesn't matter. And then we're going to have a private vector 3f color. I eventually do want to have an actual color variable that wraps a vector 3f, or maybe not even that, just a color variable. That's in the future though. And then an integer, and that is our lifetime. Then we will actually, let's just say code generate constructor. We'll give it all these variables because we do want that. And then we're going to say code generate, and we're going to say getters for these 3, and then that should be good. Okay, so now we have our class done, and I like my constructors to actually be up top. So I'm just going to move that. Okay. And then next thing we're going to do is create another new class, and we're going to say debug draw. But first, one more function. Okay, so we actually do need one more function. We're going to call this begin frame. And what this begin frame function is going to do is it's basically going to say the lifetime minus minus, and then we're going to say return this dot lifetime. So the lifetime of a line is determined in frames. So if you're running at 60 frames per second, and you say 60 as the lifetime, you'll get your line for 1 second. If you're running at 30 frames per second and you say 30, you'll get a 1 second line. So basically we're just binding the lifetime directly to the frame rate because it's easiest that way. You could technically do it in real time, but I didn't really care because I know my frame rate and I think most of you know what your frame rates are. So we will run just like that. Next, let's create a new class. We're going to call this Debug Draw. Also in the render, because these are rendering facilities. I think it makes the most sense. Now this debug draw is going to need a lot of the same things that our batched render needed. First of all, we're going to declare a private static int max lines, and I'm going to say 500 for now. We may increase that in the future. It's the maximum number of lines that we'll be able to hold. After that, we'll just simply start redrawing, removing old ones and drawing new ones. It's no big deal. Then we'll say private static list line 2D, and this will be our lines, and this is going to be a new array list. And since we do know how many lines we need, you could make that an array. It's a debug facility, so I don't see any need to worry too much about performance here. It's nice to have good performance, but you don't have to worry too much. Then we are going to have 6 floats per vertex, just like I said in that thing, 3 for position, 3 for color. And we have 2 vertices per line. So how many floats do we actually need? For our float array to contain all the numbers, well, we need vertex array equals new float, max lines times 6 times 2. So this will hold the right amount of floating point numbers for 500 lines if we just do that. Okay, and then we will need a shader. So we'll say private static shader equals our asset pool. So I get shader, and we're going to create a new shader. It's going to be called asset/shaders/debug line 2d.glsl. We'll create that after we actually get everything else up and running, but that should be good for now. And then we're going to need just a couple more variables. We will need a VAO ID and a VBO ID. So we'll say VAO ID and private static int VBO ID. And we're going to have a Boolean variable that lets us know if we have already initialized all this on the GPU yet. So we're just going to call that started. And next, we're actually going to create that start function. So public static void start. Everything in here is going to be static too, because this is a purely static class. First of all, what we want to do is we want to generate the VAO, so the vertex array object on the GPU. So this is going to be like all the initialization stuff of just getting the information onto the GPU, or in our case, getting a buffer onto the GPU. So a buffer of this size so that we can always upload to our VBO and not have to worry about not having room for our data. So we'll say VAO ID equals glgen vertex arrays. And I'm going to hit Alt-4 to enter that. And I always do the one without the C. I actually don't know what the C stands for. So GL30. Sometimes I messed up. It doesn't really matter. So don't worry if you get the wrong one too much. Then I'm going to say bind vertex array VAO ID. Next, we're going to create the VBO and buffer some memory. So we're going to ask for some memory inside of our VBO. Say glgen buffers, Alt-Enter, just to import that. Then I'm going to say glbind buffer, and this is an array buffer. And we are using our VBO ID, Alt-4, enter, and enter. Okay, and then we're going to say glbuffer data, and we're going to take in an array buffer once again, and we're going to buffer our vertex array.length. Then you'll notice it says usage, which is GL. Don't forget, we do need to multiply this by bytes, so we need to specify the length in bytes. And then we set our usage, which is GL dynamic draw. So that will just make sure that we can re-upload vertices, because we are going to be building this every frame. Okay, and then we're going to enable the vertex attributes, vertex array attributes. So we'll say GL vertex attrib pointer, and this is going to be our 0th index. This is going to be size 3. We're just going to manually specify all this stuff. GL float, and this is not normalized. The stride will be 6 times float.bytes, I think. Yep, this has to be in bytes, so it's 6 times float.bytes since we have 6 floats per vertex. And then the pointer is just 0 because this is our first one. Then we'll say GL enable vertex attrib array 0. Once again, I'm just going to copy this actually, paste it, do the same thing, and then this is going to be index 1, and I think it's actually all the same except for our pointer. This is 3 times float.bytes. So remember, this is just declaring so that our shader knows where to look for each thing. This is our position, this is our color, they're each a size of 3 floats, X, Y, Z, this is RGB. We don't care about alpha in this case. And then we're just saying it's a float, and this is the total size. We have 3 plus 3, so we have 6 floats total for each vertex. Multiply it by bytes so that it knows what size it is in bytes. This is offset from 3 from the 0th position. This is offset 0 from the 0th position. So that's what all that means. And then we'll do one more thing in here too. I'm just going to put to do set line width. I'm going to wait for that just so that you guys can see exactly what it's doing. Now, we're going to have 2 main functions that sort of control how all this works. We're going to have a public static void begin frame and a public static void draw. So begin frame will just sort of check and see if we need to remove any lines and remove them if we do. Whereas draw will literally just draw the lines. It'll create a bunch of lines and upload it to the GPU inside of this VBO. So inside of begin frame, this one's not too hard to get. One thing we do have to do is we have to say if it's not started already, we want to make sure we start and set started equal to true. So I thought, oh, I didn't make this static. I was like, why can't I find that? Okay, so make sure this is static, your started variable too. Everything is static in here. Okay, so basically this just makes sure that we actually have space on the GPU to upload our lines, just in case we haven't done that already. So it'll allocate the space, and then we can start drawing in here. And we're guaranteed that begin frame is going to happen before draw, because we need to call this first. So Next thing we're going to do is remove all the deadlines. So remove deadlines. We're literally just going to loop through int I equals 0 until I is less than lines.size, I plus plus. Make sure you don't use a for line in lines like a for each loop in here, because we will be removing as we're incrementing, which means that the order can be messed up. So you need to make sure this is correct. Then we'll basically say if lines.get I dot begin frame is less than 0, so their lifetime has expired. We'll say lines.remove I, and then I minus minus. So basically what's happening here is we're going forward through the loop. If we find a deadline, we remove it, and then we go backwards one so that we're actually onto the next line, right? Because if you have an array that looks like this, you're going through, you're here, then you're here, then you're here. Oh, I have to delete this one. Then you need to move back one so that the next time you're on this guy. And that's basically what we're doing. Okay, so that's all we have to do when we begin a frame. When we end a frame or when we draw, that's actually the harder part, because we do have to upload all the data and generate all the data every frame. But it's not too bad. It's actually pretty straightforward. So first we're going to check if lines.size is less than or equal to 0, we'll return. We don't care about drawing anything if we don't have anything to draw. Then we're going to say int index equals 0 for line 2D line in lines. We're going to loop through all the lines. Each line has 2 vertices. So we're going to say for I until I is less than 2, we have 2 vertices. Vector 2f, the point that we're currently working on, or the position, call this position, equals, if I is 0, we're going to get line.get from. Otherwise, we'll get line.get to. So this is just that we get the right position, right? So we get from first time we go through this loop, then we get to. Just save some time. You could write this all manually outside of a for loop, but this is a little bit easier. I'll say vector 3f color equals line.get color. So we get the position, we get the color. Those two things are good. Now we want to load the position into our float array, and we want to load the color into our float array. So I'll say vertex array index equals point.x, position.x, vertex array index plus 1 equals position.y, vertex array index plus 2 equals position. Actually, we're just going to set that to 0 because we have a vector 2f for our position. Let's do -10 actually too. I don't think this matters very much because we don't have depth enabled, but that might come in handy later. So then we'll say vertex array index plus 3 equals color.x. And I'm actually going to just duplicate that a couple times. Y and Z. And then this is going to be 4 and 5. And then after we finish all that, we'll say index plus equals 6. That way the next time we go through, the index will be appropriate. And then every single time we go through a line, the index will just update according to whatever vertex we're currently on. So we're just filling in all the vertices, and here it's exactly what we're doing. Next, since we just generated all that data, we want to bind our VBO and upload the data to the GPU again. So we'll say GL bind buffer, GL array buffer, and we're going to pass in the VBO ID. And we're going to say GL buffer sub data, and we're going to do GL array buffer. I don't know if we've used sub data yet, but it's basically just buffering a sub portion. So we're just going to give it a portion of our array that has the lines. And for that, we can use a function in arrays that Java gives us. So we'll say arrays.copy of range. This will copy a certain range of an array. And we're going to say we want to copy our vertex array from 0 to lines.size times 6 times 2. What this will do is it'll actually create a copy of a vertex array from 0 to the most lines that we have. So remember, we could have up to 500, but we'll only have lines.size at any given moment. And then we just upload that to our GPU. Next, we want to use our shader. Because remember, this is our draw, right? So we're first generating all the data, uploading the data. Now we're drawing the data. And we're going to upload a map for F, U projection. So we need to upload the projection and the view matrix, just like always. We'll say window.getScene .get or .camera. Okay, there we go. .get projection matrix. And then we're going to say shader.upload map for F, U view. And this would be window.getScene.camera.getViewMatrix. Okay, so we upload the projection in the view. We want to bind the VAO now. So we'll say GL bind vertex array VAO ID. Then we're going to enable the vertex attribute arrays. So let's enable 1, 0, and 1 because those hold the position and the color respectively. We're going to draw the batch. So this is a batch of lines that we're drawing. GL draw arrays. And we're going to say GL lines. So this is where we have our first big change. We're drawing lines now. We're not drawing triangles. We're going to say 0 to lines.size. And you don't have to worry about this being too slow too, because even though it's not using the rasterizer, I looked some stuff up and they might be something called, using something called Bresenham's line algorithm to draw these lines underneath the hood. I'm not sure if that's true or not, but this is basically an optimized line drawing algorithm, which is nice. Because you can't draw a line the same way that you would draw a triangle, which is called rasterization, right? If you have a triangle that looks something like that, you're going to fill it in line by line, whereas with a line, you just fill in like a pixel or two every time. So it's a little bit different. Okay, so after we do that, we're going to disable the location, GL disable vertex attribute array, 0 and 1, and then we're going to say GL bind vertex array, disable that. So we bind 0 to get rid of that, and then shader.detach. Okay, so we'll just say unbind shader. So this should draw our stuff. This isn't anything new, but I know that if you haven't been working with this stuff, it can be a little bit confusing. But basically, we just upload the position, upload the color to our copy, which is inside vertex array. So this is our local copy, right? We have this copy here. Then after we fill in our copy, we say bind the VBO, then we upload it to the GPU using this GL buffer subdata. That way, when we call GL draw arrays, it actually draws it. And notice too, this is different than GL draw elements. If we go to our render batch, when we're drawing inside here, we're doing GL draw elements. And the reason we're doing GL draw elements here is because we have this indices buffer. And so this indices buffer is also called elements, and that's why we call it GL element array buffer, but it's really just indices. And this is the reason it saves duplicate vertex data, but since we're drawing lines, these each have 2 lines only, or 2 vertices only, so there's no way we could really save data unless we search to see if any of them share a vertex, which would probably waste more time than just uploading the extra vertex at that point. So that's why we do GL draw arrays instead of draw elements, because we're just passing in the raw data instead of an index buffer. Okay. So that's that. Now let's actually add in, I'm going to call this our add line 2D method. So we're actually going to come up with a whole suite eventually. So we're going to have like add box, add circle too. But for now, we're just going to say add line 2D just to get this out of the way. We'll say public static void add line 2D, vector 2f from vector 2f2. And this will be our default one. So we'll kind of come up with a few each time of overloaded ones, which will be nice when we ever want to use this. So we're going to say add line from 2, and then we're going to actually have a few more. Let's create the full one first. So add line 2D, vector 2f from, vector 2f2, and then we're also going to be using a color and a lifetime. So we'll say vector 3f color and int lifetime. So this will be our full sort of method. Okay, and then I'm going to say this default color we'll use is just green, so 0, 1, 0. And default lifetime is 1 frame, so we'll just do that. I'm going to add a to-do here, add constants for common colors. So we should do that eventually so that we just have like, we can say constants.green instead of doing this, which would be nice. Okay. But this is fine for now. Copy that. We're going to do one more overload where they can just pass in a color. And then I'm going to say color here and take that out. So basically, these are just 3 versions of the same thing, but you can add in just your from to 2, and then you get a default green with 1 frame. This one, you get your color, but then just a default time of 1. And then this one, you can specify everything. And then we're going to say is if lines.size is greater than or equal to max lines, we have no more room. We'll just return. We won't actually add the line, but if we can, we'll say debug draw dot lines dot add new line 2D from to color lifetime. nice and simple. We're literally just adding this. This is our list of lines. So we basically check and see if we have enough room still. And if we do, we just add it to our list, a new line 2D, and then it gets dynamically created inside of our draw function and drawn to the screen. Okay, so where do we actually call that begin frame in that draw function? Well, I'm just going to do it in the window because this is the easiest place to do it for now. But basically, we can go down to our loop function, and every time right before we clear the color, what we'll do is we'll say line or debug draw dot begin frame. And right before we update, so actually this is an update and draw. So before we draw everything else, we'll draw our debug lines. We'll say draw.draw. So this will draw our lines, and then we'll draw everything else after that. That way, these are always behind everything. You could make it so that they're always in front of everything too, and we'll talk about how to do that in the future if you want to. But yeah, so that should draw it, but we're not going to get anything drawn because we don't even have a shader done yet. So let's create a shader real quick just so that we can actually draw this. I'm going to go into here, create a new file, and I think I called this debug line 2d.glsl. Believe. I could be wrong. Okay, so first we say hash type vertex and hash type fragment. Remember, this is sort of our own special syntax that we added. Then we're going to say version 330 core layout and location equals 0 is our vec2, and this is our position. So we get position and layout 0, and this is actually a vec3, not a vec2. We'll say location equals 1 is in vec3 a color, and then we're going to say out vec3 f color. We're going to pass that to the fragment just so that it knows. Then we're going to take in our uniforms here. So we'll say uView uniform mat4 u projection, and then we'll have our void main function here. Okay, so then inside of here we'll literally just say f color equals a color, pass the color through, and then gl position, so this is setting the position that will be our sort of final position, is the projection times the view times our a pose. So we just need to make sure that's a vec4 though, so we add a 1 just to normalize that. Remember, projection, view, position, or model, I guess you could call this. But yeah, and that will give us the correct position, correct color. Now we need our fragment shader so that it actually draws these onto the screen. Once again, version is 330 core, and then we'll say in vec3, we're getting an F color. Out is our vec4, this is our final color, and then we'll say void main, and very simple, we'll just say color equals vec4, F color, and 1. So always have an alpha of 1, and we literally just pass the color through. Nothing fancy, we're not going to do anything fancy, it's just lines, you know. Okay, so that should be a good fragment and vertex shader for us, though. We should actually have functionality in here now. So let's test this out. Let's go into our level editor scene. And I am going to go up here to our init method and say debug draw.add line 2d, new vector 2f, 0, 0. This should be 2f. 2 new vector 2f 800 800, just so that we're sure to see it. Give it a color of red and a lifetime of 120, so it should be 2 seconds on my screen. I'm running at 60 FPS. If I run this, we should see a line, but we see nothing. So let's figure out what's going on there. So it would help if we're actually drawing the line. I just realized this is down here where we actually break out of if our level is loaded, which it's currently being loaded every frame or every time we run this. So let's copy this and we will paste it right here. And one other thing I changed too, you may or may not see that too. It's very faint and it just disappeared because it just died. One other thing I want to mention is I did change our vertex position. No, I didn't. Okay, so this is still -10. Never mind. Okay, but you may have noticed that the line is very thin, so let's get rid of this to do, and I'm going to say GL line width, and if you bump this up, you'll notice that the line will get fatter. So if we do that at like 4.0, it's a pretty fat line, and it just disappeared. I think I'm using like 2.0. I think I like that the most. Yeah. So that looks the best to me. It's nice and simple. And let's just check out how nice it is to have this facility too real quick. So I'm going to get rid of this real quickly. Let's go down here and let's set float t equals 0, 0, f. And then inside here, I'm going to say x float x equals, I'm going to say float math.sign of t. So what we're going to be doing here is we're going to be drawing a circle with a radius of 200. I'm going to say plus 600 and then float y equals float math.cosine of t times 200, 0.0f plus 400. And then we're going to say t plus equals 0.05f, not 5t. And then we're going to say debug draw to add line to d. And we're going to say new vector to f, 600, 400, new vector to f, x, y, and new vector to f. We're going to make it red again. Let's make it blue. So 0, 1, 0, 1. Okay. And then this is going to have the default lifetime of 1 frame. So it should be drawing 1 line per frame. And you'll notice we get this cool spinning line. And another cool thing that you can do too is if we go up here and change the lifetime to, let's say, like 10 frames, we'll get a cool little blur effect. There we go. So this is pretty cool. Like, the reason we're getting this effect too is because the lines are actually lasting for 10 frames each now, so they're not dying. So those are actually 4 different lines, right? And this will allow us to do so much in the future when we need to do some sort of debug drawing and everything. Very useful to have, to be able to just anywhere in your code say, hey, add a line, and then it adds the line in world space too, by the way, that you need to see. So we'll use this in the next tutorial to actually draw our grid, but for now, this is it. In the next tutorial, we're going to be doing our snap to grid function so that we can actually snap sprites to the grid, and that should be good. And then soon we will be starting our physics engine. So those are some things that we have to look forward to. I hope you guys like this. If you did, please hit like and subscribe, and I'll see you guys in the next tutorial. Thanks. See ya.